Hey folks, yeah, let me just check if everything is all right. Uh, just give me a second, folks. I'm just trying to open the live stream and see if the audio is okay and everything else is okay. Just give me a second, folks. Okay, the audio seems good. No issues with the audio. Okay, let me also just pause it. Okay, so yeah, I don't see any issues as far as streaming goes on from my end. So yeah, things seem to be going good. No issues as of now. I'll also keep the chat window open. Yeah, let's wait for a couple of minutes for everyone to join in. Before we get going, a small announcement. I'm actually traveling. I'm actually visiting my parents and in-laws uh, uh, in Vishakhapatnam, which is a city on the east coast of India. We have a thunderstorm raging on outside. So, and I'm running everything on backup battery and the inverter. So I'm sure this will survive for an hour or so. But if you see any glitches because my broadband connection is down because of the weather outside, I will have to, I'll try and rejoin over my mobile connection. And if I cannot join even from my mobile connection, we'll have to terminate this live session. Fingers crossed. I hope it all goes well. But yeah, let's see. Yeah, I'm running on backup battery. My broadband seems to be working reasonably okay, if not great. But I don't know when anything can break down, right? As there is a thunderstorm right outside. Let's see. Okay, sounds good. Okay, some of you are already in here. 1 second. Okay, okay. Yeah, somebody's asking for a new batch after May 20. We'll surely do that because from May 15th, we believe most students in BTech third year and final year, their exams will be over by May 15th. We'll actually start batches more frequently during the summer so that people can join. Right now, we have like what? We have like 20 days for one batch to other batch. So in summer, I mean, after May 15th, we'll try and do it more frequently and we'll try to organize batches in such a way because there is more time in the summer. So that's what we will do. Somebody is asking about the next subject. We discussed this in the previous live session, right? We'll send out the schedule for linear algebra tomorrow. We'll also start putting out content. We start calling some of you in the order of you joining applied course. Some of you have suggested us that it will be great if we could upload all the content the previous day night itself, because there are some students who are waking up at 5 a.m. or 6 a.m. and spending the early hours of the day going through the content because they have to go to either college or work after that. So we completely respect that. So we will be pushing out content by late night every day. The content for the next day will push out the night before itself. Okay, so that even if you're waking up at 5 a.m. or 6 a.m. to go through the content, you should not have issues. Okay, sounds good. So that's a valid suggestion that we got from some of the students. Right now, we are pushing early in the morning before 8:30 a.m. But from linear algebra onwards, we'll try and push it the previous day night itself, right? So that Balaji, it's okay. I mean, I don't want to skip it because still things are working, and I don't want to get out of this habit of doing it regularly because it's a very common problem that most of us have. That if you start skipping once, it becomes a habit, and you want to start skipping every time. I think you've seen this background also, right, in the previous live session. So I've been visiting my parents and in-laws, and yeah, wherever I am, the live session should happen unless I'm sick or unless I can't really do it. So I don't want to make excuses because I need to put in my side of the bargain. Today we did not have any practice questions, but we thought, okay, there is a subject test, right, that we gave, I think, on 18th. I thought I'll do some problems from it. Of course, it'll be hard to finish all the 25 problems, but I'll do a few problems. By the way, we also uploaded the second practice test for C programming in the evening hours today, which you can try it tomorrow. From day after tomorrow, we'll start linear algebra, right? And very importantly, as some of you have suggested us, we'll push out the content for Monday's linear algebra, we'll push out by Sunday night. Similarly, for Tuesday's content, we'll push out by Monday night. Because there are some of you who are religiously waking up early in the morning. to cover the content. We want to respect their time and their effort, right? So we'll do that. Sounds good. Please first complete discrete maths, and can we please first complete discrete maths and COA after May 20th? You're talking about computer organization after May 20th? I couldn't understand that comment. Don't worry. I mean, probably till May 15th, we'll cover some of the easier topics and also some of the topics where which are not, which of course, there are some topics from which you can never imagine how many questions will come, like linear algebra, right? But I might spend more time on linear algebra. I was writing all the notes and creating some videos today. I want to focus, again, I come from a hardcore machine learning background. I worked in machine learning for most of the last 10 to 12 years. So I've used linear algebra on a day-to-day basis, literally. Like I actually used matrix inverse. I actually used matrix eigenvalues, eigenvectors on a day-to-day basis. So I'll try to explain you linear algebra, not from a purely numeric perspective, but also from an intuitive and geometric perspective. I've done it partly, of course, not very thoroughly, but partly I've done it in the AA course. So I'm excited to teach math because that's my first love. And of course, algorithms is a type of mathematics. If you think about it think about it, it's basically discrete optimization. So we'll start with linear algebra, then we'll go and cover a few topics that students who have exams can come back and revise. And as we mentioned in the last live session also, we will be doing fewer content, smaller chunks of content, maybe 1.5 hours or 60 to 90 minutes every day instead of the 2 to 2.5 hours. So that those people who have exams can cover these topics post their exams after May 15th, because it's a vacation time mostly, right? From May 15th, we'll go double down. We'll double down whatever we are lagging from 20th of April to May 15th. We'll compensate for that from May 15th to May 15th onwards, right? So yeah. So we plan to, somebody's asking about, so somebody's asking about loop invariants. We discussed loop invariants in data structures and algorithms, right? So the topic has already been covered in a slightly different context. So you're talking about structure padding. Okay, so we can do that, certainly. So there are some of these small topics, which again, we try to focus more on gate syllabus, to be honest with you. Otherwise, otherwise we can just take GCC, the C compiler, open it up and go through line by line. So that will be fun, but we don't have the bandwidth for it right now. So somebody's asking about live sessions. Can you do live session for the subject again, which is completed by previous batch? Yes, we'll do that. Don't worry. See, every batch will get their own live sessions. Don't worry about it. And for example, if batch 1, so for example, we have batch 2 right now, right? For batch 2, data structures and algorithms are not over. We'll certainly do them at a later point. Batch 1 students who want to join those live sessions, they can also join, right? Batching is only about the start date. All of us have the same end date, which is early February, when all of us have to write the GATE exam, right? So the end date is the same. You can repeat the same subject as long as you want. You can rejoin any batch and participate and practice questions with that batch. Okay, so don't worry about that. Okay, so yeah, we plan to finish most of the subjects for batch 1 by early September or late August to early September. Again, it all depends on how much response we get during the summer months, right? So from May 15th, from the time the exams are over, from May 15th to till early July, right? That's a vacation time for most students. If students can put in more effort, cover more subjects at that time, I'm very hopeful. We have some tentative plans, and we think we can cover it by late August, early September for batch 1, and third or fourth week for batch 2. Right? So that's the tentative plan right now. Of course, there might be small reordering like this, right? So we actually thought of starting whole of discrete maths and finishing discrete maths in about a month's time, month to 40 days. But then we can't do that right now because some of you have exams. And when we wrote that syllabus, we forgot to compensate for that. But don't worry. See, there will be push and pull, and sometimes we'll have to accommodate some of the students who have exams like this. Sometimes we'll push more and more content, especially after their exams. Okay, so don't worry about that. So let's go and look at some questions. I mean, I've solved a bunch of questions from the practice test. We'll not be able to cover all the problems. I've solved some 15 problems just before this live session. And these are 15 random problems out of the 25 problems in the practice test. And the practice test is timed, as you all know. And below every question, you'll get an answer. After you've answered the whole thing, you'll get detailed answers for everything. Okay. So, sounds good. Yeah, look, we will cover important questions, or we'll cover questions from previous GATE questions. Certainly, I mean, they will be covered either in practice problems, or in subject tests, or in solved problems, or in mock tests, or combinations of subjects. See, at the end of the day, our goal is for you to have practiced at least 3,000 to 4,000 problems. Think about it, right? If you practice genuinely, if you practice 3,000 problems, right? And I discussed multiple times about how to practice problem solving, right? You take up a problem, challenge yourself not to look at the solution. Try to solve the problem, struggle with the problem, right? Because that struggle builds up your skill of problem solving. Struggle with the problem, don't look at the answer, right? That's why from the time we give you a practice test to the time we give you answers, we take some time. And the reasoning for that is we want you to struggle with these questions. Try not to look at the answer, try to struggle and solve each of the problem, because that struggle teaches you how to think and solve problems, right? So our goal is to have every student at applied course solve at least 3,000 to 4,000 problems, and hopefully more, right? If you can accommodate, we want you to solve 5,000 to 6,000 problems. And that's like a deadly combination. At the end of the day, GATE boils down to problem solving. Okay, how much ever theory you know, if you cannot solve problems, you'll not crack it. So we will ensure that you have ample amount of world-class practice for GATE. Okay, again, as one of the core tenets of the course itself is practice, practice, practice. Because that's what, from our own personal experiences, is the key thing for you to crack GATE. From a lot of advisors, a lot of people that we've talked to, even my own personal experience. Okay, so let's dive into some questions now. Okay, it's already 15 minutes in, so I'll try to cover, share. Okay. Yeah, today I can't do the typical interface because the exam is timed, so it'll time out before we go ahead, right? So let's go through each of these problems. Okay, so let me just open up my. Okay, so let me just open up. Give me a sec, folks. Okay, let me see. Okay, I have the red color here. So let's look at this problem, and the problem says, what is the output of the following program? Let me just scroll down a little. Okay. Okay, the answer is already here, but let's work it out, right? Because this is the answer sheet. So once you finish the exam, the solution report looks like this, which will tell you what is each of the solutions and some explanation about the solution. But let's go through each of these problems now. So what does it say? Include stdio, int main, player equals to 1, switch, player less than 2 plus player. So this is a bitwise left shift operator, right? What is 2 plus player? 2 plus player is 3, because player equals to 1. So what do I have? I have player left shift 3, right? What is player? Player is initially equal to 1. So in binary, what is in binary? If I take 1 byte, right? This is what 1 is represented by, right? We have discussed this. This is 2 power 0. This is 2 power 1, so on and so forth, right? Now, all that is good. Now, when I left shifted by 3, what happens now? So this will become 0, 0, 0, 0, 1, 0, 0. And what is the equivalent value for this? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Right? So this is equal to 2 power 3, which is equal to 8. Right? So switch, what is the value here? Player left shift this, which means this will evaluate to a value of 8. Right? Where is the value? You have a default value, case 4, case 5, case 8. In case 8, I'm saying printf MS Dhoni, right? So it will actually print MS Dhoni. Very simple question. Again, some of the questions in these practice tests are simple by choice, because we want students, especially those who have not had enough practice or who couldn't put in a lot of effort, not to feel discouraged. Okay, so some of these questions are simple, but as you will see, as you progress, there will be more and more harder questions. Okay, so let's look at this. This is also a very nice question, actually. So which one is not an illegal pointer operation? Not an illegal pointer operation. So there is a negative here and there is a negative term. The question here is, which of them is a legal pointer operation? Addition of 2 pointers is not valid. Okay, because there is not an illegal. Not an illegal basically means legal, right? So which of them is a legal pointer operation? If you notice, addition of a float to a pointer, this is not valid, but addition of an integer to a pointer is valid, because we have seen this, right? We have seen we have seen that this is equivalent to PTR2, right? We have seen this. Okay, this is how we translate from the array indexing to the pointer notation. Okay, so here what are we doing? We are adding a numeric value or an integer value, right? To be precise, an integer value is what we are adding to a pointer. So this is valid. So if you notice, bitwise operations between pointers is not valid. Addition, it could return in a illegal pointer operation, but integers can be added. That's perfectly valid, right? So this is a legal operation. Rest of them are not legal operations. Okay, I hope this is clear. Okay, so now let's go to the third question. Okay, so somebody is asking about will we be providing 3 to 4K problems during the course? So let's be frank here. I'm not saying that we'll be exactly providing original questions. Let me just stop screen sharing here. I'm not saying we will be providing all the questions, right? But our goal, for example, if you see any of the chapters that we have already done for any of our batches, they end up solving a few hundred problems in the very first iteration, either through solved problems or practice problems. Our goal is that every student eventually finishes solving 3 to 4,000 questions. That's our goal. Okay, and we'll try to break it down. In some instances, for example, for many of our students for C programming, those students who have finished all of the practice problems that we gave. Okay, so yeah, one of my teammates is saying that the second test will be trickier than the first test, and as I told you, that's by choice. So about this question about 3 to 4K problems, yes, we will try and provide these problems, but there is a lot of responsibility from the students' end also, right? In the sense that if you just look at last 30-year questions, right? Just look at last 30 years of questions, right? We have close to almost 1,500 to 2,000 questions just in the last 30 years of GATE questions, right? And we are regularly creating new questions. The mock tests that we did last year, right? There were 5 mock tests last year, all original questions, right? Those 5 mock tests were about 350 questions. This year we'll have tons of mock tests, right? And of course, we'll have tons of problems that we will be giving, right? At any point, if you think your practice is not sufficient, do let us know. Okay, we'll try and provide you references or pointers or more problems, because at the end of the day, we want you to solve at least 3 to 4K problems, and we will help you in that process. But it's a shared responsibility. We will provide you pointers to all the problems. Anything that you're stuck with, we'll help you solving them. But at the end of the day, you have to sit down and solve. Okay, that's very, very important. I cannot emphasize more on that. Okay, sounds good. So let me screen share this again, back to the problem itself. Okay, so let's go to the third question here. Hey, again, as one of my teammates is saying, the second practice problem, yeah, you can hear the thunderstorm outside. I don't know if the microphone is picking those things up. But the second test will be trickier and harder than this, obviously, because we gave the first test to be slightly easier because we don't want anybody to be demotivated. Okay, so let's go to the third question here, right? What does it say? I have a function f which is recursive, right? And I'm saying int val equals to f5. So what will f5 be? Because I'm trying to print val, right? So if you notice, what is f0, right? If you look at this recursive function, it says if n equals to 0, return 1. Very simple. What about f1? f1 is fn minus 1, which means f0 minus n, right? N is 1, plus again fn minus 1. Sorry, plus n minus 1. So we have fn minus 1, fn minus 1. So it is 2 into fn minus 1. So 2 into f0 plus 2. What is this? This is nothing but 2 into f0. f0 is 1. Minus 1 plus 2 is plus 1. Right? So this is equal to 3. What about f2? f2 will be 2 times f1 minus n. Right? You have minus n here. What is n? N is 2 plus 2. So minus 2 plus 2 will cancel out. 2 times f1, which is 2 into 3, which is 6. Right? What about f3? f3 is 2 times f2. 2 into 6 minus 3. N is 3 plus 2. So this is 12 minus 1, which is 11. Right? Similarly, what is f4? f4 is 2 into 11, 22. 22 minus 4 plus 2. So 22 minus 2, which is 20. So what is the question? The question is all about f5. Right? This is what it is all about, right? f5 is 2 into f4, which is 40, minus 5 plus 2. We have minus n plus 2, right? So minus n plus 2. So what would this be? 40 minus 3, 37. So this would actually print 37 as the answer. Very simple recursive program. If you know how recursion works, this is a trivial, straightforward problem. Okay, again, this is to warm you up, to be honest. Okay, so now let's go to the fourth problem. Okay, it says, consider the following declaration of a two-dimensional array in C. Okay, this is how I'm declaring my array, A 100, 100. So it has 100 rows and 100 columns. Assume the memory is byte addressable, because this is a character and each character is 1 byte. Assume that the main memory is byte addressable. Okay, we'll discuss non-byte addressable memories when we discuss operating systems, computer organization, etc. Okay, and that the array is stored starting from memory address 0. What is the address of? So the starting address is 0, which means A00, right? A00 is at address 0. Then what is the address of A4050? So we discussed about row major order, right? We discussed about row major order, right? So before I store a 40th row, I would have stored 0th row, first row, second row, so on, 39th row. I would have stored all these rows, right? How many rows are here? There are 40 rows here, right? And each row in the character array, each row has 100 columns. So I would have already stored 4,000 characters already. And if each character is 1 byte, right, I would have already stored 4,000 bytes of information. Then my 40th row will start. And I want 40th row, 50th column. So before I reach 50th column, I would have column 0, column 1, column 2, so on, column 49, and column 50. Right? So before I reach the column 50, right, I would have crossed 50 columns, because 0 to 49, I have 50 columns here. So I have 4,000 bytes here, which are covered by the first 40 rows, and I have 50 bytes which are covered by this, right? So the location of this will be, because the starting location is address 0, the location of this, the 40th row, 50th column item will be 4,000 plus 50, which is 4,050. Okay, so we have discussed about row major order and how C stores these two-dimensional arrays internally, right? Very simple stuff, very straightforward. Okay, sounds good. So let's look at the fifth. So let's look at the fifth question now. Okay, so this is slightly tricky, but it's doable. Okay, so let's look at. Okay, let me just scroll this a little up. Okay, so let's look at this question. It says I have a function called q. Look at this. X is a global variable, right? X here is a global variable. I have void q, I have p, and I have main. So x equals to 5. Okay. So in my main function now, my x equals to 5, right? And I'm calling the function p. Look at this. I'm calling function p by passing the address of x, which means I'm passing the address of this here, right? So this is pass by reference. Okay. And here I'm taking an integer pointer. Perfectly all right. Now, what am I doing here? Here I'm saying, here I'm creating again a local variable called x, right? So if I'm referring to x here within this scope, there is a global x and there is a local x. And local x will take precedence over global x in this block or in this function, right? So x equals to value stored at y. What is value stored at y? Value stored at y is nothing but 5 plus 2, which is equal to 7. This is a local variable. This is not a global variable. Remember, this is the global variable, right? This is the global variable. This is the local variable. Very important to remember. Then I'm saying qx. Now here I'm calling again a function q, but q takes pass by value, right? So I'm actually calling q7, right? Because the local value of x is 7, right? So now what does it say? It says z equals to, right? So z equals to z plus x. So when it says x, it is referring to the global x, right? So what happens here? I have z equals to, so what is z already? Z is the name of the formal parameter, which is 7, right? So z equals to 7 plus the global value of 5, right? Which is equal to 12. So z equals to 12 now. Print z. Okay, I'm saying print z. Now, if you notice, here I've defined print as, so wherever print x is there, it will print it as printf %dx, right? So because of that, what it print? It will print z, which means it will print 12, right? It will print 12. Now, if you look at the options in the answers, right? If you look at the options in the answers, You have 12, 7, 6, 22, 12, 11, 14, 6, 6, 7, 6, 6. Because the first thing that got printed was 12. Instead of, again, rerunning all of these function calls, you can directly answer A without solving it. Because remember, this is a 1-mark question, if I'm not wrong. I think this is a 1-mark question, right? So for 1-mark questions, you should not spend too much time. You should solve it fast. Okay, as soon as you got an option, a printed value of 12, just see if there are multiple options which are printing 12. No, there is only one option that is printing 12. So A should be the answer. Of course, if you keep running it, you'll get 12, 7, and 6 as the answer. Again, we have pointed to some online coding platform where you can actually test this code yourself. Okay, so let's go to question 6 now. So how does this work? Okay, so I have int main, right? I have a static variable x. Because this is static, it is by default initialized to 0. We discussed about static variables, right? By default, they're initialized to 0. Now I'm calling this function increment, semicolon, increment, increment. Okay, so first increment will be called. So x equals to 0. X is now pre-incremented. Look at this. So x becomes 1, and then it will be printed. So the first thing which will be printed is 1. But this also prints 1, this also prints 1. Okay. Again, I call inc. When I call inc again, because this is a static variable, it will not be reinitialized to 0. I'm just going to increment whatever value it has, so I'll print 2. Again, when I call, I'll print 3. Right? Very, very simple. The key concept here is that it's a static variable. That's it. As soon as you understand that, this is a straightforward problem. 1, 2, 3. Okay, very simple, straightforward problem. Okay. So now let's look at this question. This is an interesting question. Okay. So here, if you notice, okay, this is almost straightforward here, right? So we discussed this when we discussed about. So if you look at this, I have 2 character pointers pointing to first and second. Very good. Now I'm saying switch this. Okay. If you look at each of these cases, they're strings. If you look at each of these, they're strings actually, right? So because of this structure of switch case, this will actually result in a compiler error. Okay, because we need a constant expression. Expression should not be a string, right? We wrote that error here also. Okay, the expression cannot be a string. It has to be a character. It has to be an integer value in a nutshell, right? So this will result in a compiler error. Okay, so let's go to question 8. Again, this is straight from the theory, right? Nothing very fancy. If you have gone through our videos for switch case, this is straightforward because we covered it very explicitly. Okay, now comes the fun. This question is actually fun. Okay, I think there is a small error in this question, but let me explain this. Okay, so I have an integer array. Look at this. I have an integer array which is storing 10, 20, 30, 40, 50, and 60. Right. So my array, my ARR is a pointer to the 0th element, 0, 1, 2, 3, 4, 5th element. Right. Array is a const pointer, const integer pointer going to point to this. Now I'm creating another pointer called ptr1, which will also point to this, right? I'm creating an integer pointer which will point to this. I'm creating an integer pointer ptr2, which will point to array plus 5. Okay, which means it will point to 1, 2, 3. So it will point to this. Okay, this is where ptr2 will point to. Now look at this. Now what does it say? Number of elements between the 2 pointers is ptr minus ptr2 minus ptr1. Okay, so when I do ptr2 minus ptr1, okay, 1 second, 1 second. What is a print statement? Just a second. Anyway, I think there might be an error in something that I said. One of my teammates is pinging me. Anyway, we'll come back to that. I think this is related to question 7. Anyway, so since I'm not there, so in the current question, right? Yeah, I'm not saying there is an error. So I think one of my teammates is currently confused. Okay, that's okay. Let me go ahead with this. This is not an error, right? So there is no error with this question. I was not sure whether he meant the previous question or the current question because we are not together. If I make a mistake, somebody corrects me right away when I'm at office. But that's okay. Let's go with this. So here, what are we doing? Here we are actually ptr2 minus ptr1, right? So, okay, this ARR is a pointer. That's perfectly all right. ptr1 points to this, ptr2 points to this. Okay. So now let's see number of elements between the two pointers are ptr2 minus ptr1. Now, if you notice, what is ptr2? Because these are integer pointers. Because these are integer pointers, ptr2 is ptr1 plus 5. Right? So if when I perform ptr2 minus ptr1, it would actually print 5. So it would actually print 5. Right? Because remember, ptr1 and ptr2 are integer pointers. Okay. So it'll actually look at the number of, oh, I think my teammate Naveen is saying that there is no error in this program. I'll tell you, I think there is a small error in this program. I'll tell you what my concern with this question was. Okay, I'll come to that, Naveen. Don't worry. Okay, now I understood your context. Okay, so let's go. If you run this program, it will not give you an error. Okay, but the output could be slightly different from one computer to other computer. That was my concern. That's it. Okay, so let's go through it. So ptr2 minus ptr1, because there are 5 integers between this pointer and this pointer, it will print 5. Now let's look at the next one. It says number of bytes between the two pointers are. Look at this. What am I doing here? I am now converting this ptr2. Remember, ptr2 and ptr1 are integer pointers. Now I'm converting them to character pointers. Okay, so now I'm typecasting them by force into character pointers, right? And then I'm subtracting them. Now, let's assume int is 4 bytes. Let's assume int takes 4 bytes on our computer. Okay, let's take int takes 4 bytes. Now I have made my pointer 1 as a character pointer, my pointer 2 as a character pointer, right? How many integers are stored in between? If you notice this, how many integers are there from the starting of this location to the starting of this location? There are 5 integers, right? If each integer is 4 bytes, right? If each integer is 4 bytes, and we know each character is 1 byte, right? Because I've made it into character pointers. We know each character is 1 byte, right? So now what do I get? I get 20 bytes, right? See, the answer number of bytes between these two pointers is 20. That's what it's printing. But imagine if my computer stores my integers in 2 bytes and not 4 bytes. Okay, then the answer would be 10 by 10, not 20. Or if my computer, for some reason, if my computer stores integers in 8 bytes, right? If it stores integers in 8 bytes, right? Then my answer, it will print 40 and not 20. If my integer is 2 bytes, the answer will be 10 bytes, right? And not 20 bytes. That's what I was saying is one small boundary case in this. So if you actually run this program on most computers, which actually inherently store integers using 4 bytes, you would get 5 and 20 as the answer. But the C programming language doesn't say that ints have to be stored in 4 bytes, right? It never says that explicitly. You can store int in 2 bytes or 8 bytes. It's up to you based on your compilers and your computer's interpretation of how you want to implement it internally, right? So most computers you will get 5 and 20. That's certainly true. But even so, here I had mentioned that this question would be complete if my team actually wrote that on this computer int takes 4 bytes. Then this question is perfect. Otherwise, there is a small case that somebody could say, no, on my computer int takes only 2 bytes and it would never print 5 and 20. Okay, so that's a small problem in this question. That's it. I think that's what my teammate Naveen was pointing to. Okay, I hope this is clear. Okay, this is not to point mistakes, just to figure out that there is this small boundary case which we wanted to see. Okay, so now let's go to this question 9. Okay, I'll try to solve as many as we can. So let's go to question 9. Okay, some of these questions are easy, to be honest. Okay, here I am defining something called swap1 with 2 parameters a and b. So wherever there is swap1 ab, this is what it would get replaced with. Now I have a function called swap2. I have a function called swap3. Now let's look at my integer. Okay, my main, sorry, not integer. Let's look at my main now, right? Let's look at my main function. I have num1 and num2. Okay, I have num1, num2. My num1 is 5. My num2 is 4. Very good. If num1 is greater than num2, then swap. Okay, we have seen swap1s, right? Swap1 is defined using hash define, right? Swap1 is defined using hash define, right? So what happens now? It's basically going to swap these two values. So after that, This condition is true, so it will swap these two values. It will become 4 and 5. Very good. Now, if num1 is less than num2, right? So if num1 is less than num2, right, which is the case, num1 is less than equal to num2, right? Sorry, strictly less than num2. Yes, this is the case. Then it's calling this function called swap2. But if you notice, it is passing num1 and num2 by value, but not by reference. Look at this. This swap2 takes values by value and not by reference. So whatever swapping it is doing here does not reflect back here, because this function swap2 takes values by value and not by reference, right? So whatever swapping it is doing internally will not reflect in the calling function, right? So in the main function, remember, in the main function now, in the main function, my num1 and num2 still remain 4 and 4, 4 and 5. While internally, this a and b values got swapped. Okay, but because I'm passing by value, they don't change in the calling function. Now the third case, it says if num1 is greater than equal to num2. Num1 is not greater than equal to num2. It's not. So this swap3 function will not even be executed. Remember, this swap3 function actually takes by reference. So whatever changes it makes will be reflected back here. But this function wouldn't even get called. This swap3 function wouldn't even get called because this condition is not satisfied, right? So 5. Okay, I think I'm live again. I think just let me see. Hello. I think I'm live again. I just reconnected. Just can you check and confirm, Naveen? Hey folks, can you confirm now? I think it took a split second for the inverter to kick in. Am I audible and visible? Just wanted to check that with everyone so that we can continue. Okay, sounds good. Sorry, folks. Sorry for that. Okay. Okay. Sorry for the small hiccup. Yeah. Yeah. Thanks, Naveen, for letting me know, because I would have kept recording without realizing that the live was off. Okay. So let me just share the screen. Okay. So let's go in again. Yeah. I hope this answer was clear, right? So this answer is straightforward. This answer is 4 and 5, right? So I don't know where we left off, but it's a straightforward thing. The key thing in this problem is what you realize here is that swap2 takes parameters by value, right? So any swapping that it does will not impact the variables that are there in the calling function, right? So that's the key value here. While swap3 is a function that takes addresses and hence is calling these functions by reference. That's the key takeaway, right? So as long as you understand that, I think we are cool. So now let's go to question 10. Okay, so this is a slightly tricky question, but let's do it. Why not? Okay. So I have a function called swap. I have a function called print tab. Okay. Okay. I'm calling, so swap is taking values by reference, swapping them gracefully. Very good. So this is actually swapping by reference. So this will work perfectly. Now, first I'm calling this function called print tab, wherein I'll go here. And remember, these are static variables, right? So my I is not initialized, so I will be 0. My A will be -3. My B will be -6. But anyway, I'm declaring I equals to 0 here clearly. So I equals to 0. While I is less than equal to 4. Okay, what is I? Now let's say now I equals to 0. Okay. Now, if I plus plus percentage 2 equals to 0. Okay. So first, this will check everything. Then it will increment I. Right. So I plus I modulo 2. I modulo 2 is equal to 0. Okay. So this condition fails. So it will not continue. But internally, I will become 1. So I'll go into the loop. I'll go into this. I will not continue. I will not continue here. And I'll actually, I will get incremented to 1. As soon as this statement is over, I will get incremented because I have I plus plus here, post increment, right? Now A equals to A plus I. So A equals to minus 3 plus 1, which means it will become minus 2. What about B? B equals to B plus I. B equals to minus 6 and I is 1, which means it will become minus 5. Very good. Next, I have I equals to 1. So my I is already equal to 1, right? Now my I is already equal to 1. So then it will go and check for this condition. Look at this code. Okay, I'll check for this condition. I is less than equal to 4. Very good. Now, is I modulo 2 equals to 1? Yes, because this is an odd number, right? Hence, when I divide it by 2, I'll get a remainder of 1, right? So what does it say? So as soon as this is over, I will get incremented. So I will become equal to 2, and then I will continue. What does continue do? Continue will go back here, right? So this is what is happening in the second loop. Now my I equals to 2. Is I less than equal to 4? Yes, very true. Then is 2 modulo 2 equals to 1? No. Now what is my I? My I equals to 2, right? 2 is an even number, so it will not continue, but I will get incremented to 3. Now what will happen to my A? My A is minus 2 plus 3, which means it will become 1. What happens to my B? My B is minus 5 plus 3, which means it will become minus 2. Okay, very good. Now, what is my I now? My I equals to 3. Let me write down a couple of more iterations, right? So let me write down a couple of more iterations now. Okay. So now my I is equal to, I equals to 3. I'm sorry. So my I is equal to 3. 3 is less than equal to 4. Very good. Is 3 modulo 2 equals to 1? Yes. Because 3 is an odd number, right? So I would get incremented. And I'll continue, right? Now what is the status of my I? Now my I equals to 4 and I is less than equal to 4. Very good. So I'll come in here, right? Is my 4 an even number or odd number? It's an even number. So I'll not continue here, right? But my I would get incremented to 5 and my A would be, A's current value is 1. 1 plus 5. So A will become 6. What about B? B will be minus 2 plus 5. So B will become 3. So 6, 3. So when I print, so it is 6 and 3, right? Sorry, this is 6 and 3. Now I'm calling this function called swap. When I swap, what happens? A becomes 3 and B becomes 6 because I'm going to pass this by reference. Now when I print A and B, right, their printed value will be 3 and 6. Okay, let's see which options. Sorry, A is, sorry. One second. I think I messed up somewhere. 1 second. My A, 1 second. Did I mess up somewhere? My A is equal to, my A is 1, right? So my A is 6 after swap. Okay, 1 second. So what is the order in which I'm printing here? Just a second, folks. Just let me erase this. So what happened at the end of this? I think I made a small mistake, or did I not? Just a second. Okay, just give me a sec. So A equals to 3. 1 second. Okay, let me actually run the swap function. Let me see what actually happens in the swap. Okay, let me just do that. So A equals to 6, B equals to 3. Let's actually go to the swap and see what happens in the swap. Okay, so what did I pass? I passed, so let me go and see how the swap is implemented. Okay, let's do it carefully. So, right, so what is the value? So I passed A here and I passed B here, right? And A had a value of 6 and B had a value of 3, right? I passed their addresses. Okay, I passed these addresses. So what is happening now? Static int temp is an int pointer. So A is now, so X is now a pointer to this memory location called 6, which has variable A, which is pointed by variable A. My Y is a pointer to 3. This is what it is, right? Now what does it say? Temp equals to X, right? So temp will point to this. Okay. Oh, this is dummy. Okay, I got it. Okay. Just exchanging pointers. Sorry. Okay, let's actually run it through this. Okay. This is a tricky case. I almost fell for it. So temp points to this, right? Temp points to x equals to y. So x will point to this, x will point to this, x will not point to this anymore. Y equals to temp. So y will point to this. So x is going to point to this and y is going to point to this. Except that if you notice, these values did not change. We did not swap the actual values. We only swapped the pointers. Okay, I almost fell for this trick. Okay, this is a swap of pointers, not the values themselves, right? So when I go back to the calling function, what is the value of a variable a? It will still be 6. What will be the value of b? It will still be 3, right? So when I actually go and print now, sorry, that's a good trick actually. Okay, so this swap is actually not swapping. This is basically swapping only. This is not swapping the values. This is only swapping the pointers, right? So I had a equals to 6 and b equals to 3. So when I print it, when I print a and b, I'll print a equals to 6 and b equals to 3. I don't have to run the print tab again. Okay, I almost fell for this trick. It's a good trick. Good question actually. Okay, I think yeah, I almost fell for it. Good one. So yeah, so that's what it is. So this is swapping the pointers, not swapping the values as we just saw. Very good one. Good question actually. Okay, so let's go to question 11 now. Okay, this is a very good question. I really like this question. Again, this is tied to some linear algebra that we'll see. That's why I really liked it. Okay, I have a character array. I have a character two-dimensional array here. How does this array look like? This array has 2 rows and 3 columns. Okay, this A is a 1D pointer. 1D, it's a pointer to a 1D array. If you can think about it, or a double pointer, right? That's how we think of these names of 2D arrays, right? So here you have A, B, C, D, E, F. That's what you have. And you have another array, right? You have another 2D array here called B, but B has slightly different dimensions. B has 3 rows. Look at this. B has 3 rows and 2 columns. Okay, so B is slightly different. Now, what does it say? It says P equals to char star P. So B is a 1D array pointer. Look at this. B is a 1D array pointer, while P is a character pointer. Look at this. P, the value stored, so the P is a character pointer which has star B, which means it will point to this character that is here. Okay, remember, we have discussed this extensively, right? You can think of A as a double pointer, B as a double pointer, but P is a single pointer or a char pointer to be precise. Now let's look at this. This is the fun part. Okay, let's look at this. It says I equals to 0 to 2, j equals to 0 to 3, I plus plus, j plus plus. Okay, so what does it, let's look at this statement now. So for I equals to 0 and j equals to 0, what happens? What does this statement look like? It looks like star p plus 2j. 2j is 0. I is also 0, right? 0 plus 0, value stored at p, sorry. So it says value stored at p equals to aij, a00, right? So what will be the value stored here? Value stored at p, because p is a pointer to this character. It's a character pointer, right? Look at this. P is a character pointer, right? So value stored at this is a00. What is a00? A00 is this character a. So we'll store character a here. This is good. Now what happens? Okay, now what happens is interesting. Now j will become equals to 1. Right? Look at this. It's a twin loop, right? You have I equals to j to I equals to 0 to 2, j equals to 0 to 3. So I will remain 0, j will become 1. Now what do we have? You have star p plus 2j. What is 2j? 2j equals to 2 plus I equals to 0. Right? So this is what you have. Okay, star p plus 2 is what you have. P is pointing to this. What will p plus 2 point to? Remember, p is a character pointer. So p plus 0 is this, p plus 1 is this, p plus 2 is this. And it's saying the value stored at, what is it saying? Value stored at p plus 2 is equal to a01. What is a01? 0th row, first column, which is b. Right? See, it says ab. If you continue the same loop, actually, you don't have to continue through the whole loop. See, look at this. You have AB, right? So finally, what it says, the question here is, what should be the contents of array B at the end of the program? So what did we get? We get A, B. Rest everything we don't know yet. Okay, this is what we already got. Look at which option satisfies this. Option B satisfies this because I have A here and I have B here. Right? So this doesn't satisfy because I have AC, I have AE here, I have AD here. Right? So literally, if you run through this whole loop again and again, if you run through this whole loop, what will happen here is you'll get ABC, you'll get ABC, DEF. Okay, that's what you'll get. So for those of you who already know matrices because you've studied them in your 11th and 12th class, you can think of this as B equals to A transpose. Right? You can think of this as transpose. See, basically, I'm converting a 2 cross 3 matrix, 2 rows and 3 columns into a 3 cross 2 matrix. Okay, so this is the code, this is the C code to compute the transpose of a matrix. Okay, anyway, we'll discuss, for those of you who've forgotten it, we'll discuss this in detail later on, okay, in matrix algebra or linear algebra. So now let's go to question 12. So what does this question do? What does this question ask? It gives me P1, P2, P3. So it says which of the above 3 functions are likely to cause problems with pointers. Let's look at this, okay. So let's go to P1. So what are we doing? We have, so it's returning a function pointer, very good, not taking anything else. Int x equals to 10. So x is a local variable, and I'm returning the address of a local variable. But remember that this local variable will be deallocated from memory as soon as this block is over. So I'm going to return the address of a location of a variable, literally of a variable, which will be deallocated from memory anyway. Okay, which will be simply out of scope completely, right? So, so this is not a good practice. So this can create problems. So P1 can create problems. What about P2? What am I doing here? So if you notice, I'm returning int star, very good, G, very good. I'm creating a pointer. See, look at this. Here, I'm creating a pointer. So the moment I create a pointer, this P will point to some random garbage location, right? Because I'm not initializing to anything. I'm making it point to some random garbage location. Right? I've not used malloc here. Ideally, what should I do? I should create some space to store an integer, and px should point to that space, and I can fill this space with 10 now. Right? I should fill this space with 10. Here I did not use malloc, hence it can create problems. So P2 also can create problems. What about P3? Look at this. In P3, everything is good because here I'm allocating some memory, which is the size of integer, and that I'm doing the typecasting perfectly. I'm making it point to px, and then now I'm storing the value of 10 in this memory location, which is pointed by px. So this is perfectly all right. P1 and P2 can create problems, right? That's what we have. We have P1 and P2. Okay, only P1 and P2 will cause problems with pointers. Okay, so now let's go to question 13. Okay, this is a good one actually. I really enjoyed solving this. Okay, which one of the choices given below would be printed when the following program is executed? Okay, so look at this. I have a structure called test, which has an integer and a character pointer. ST is an array of structure test, right? And I have these 5 become. So 5 and become will be part of ST0, right? This is your ST0. This will be your ST1. This will be your ST2. This will be your ST3. This will be your ST4. Now it says structure test pointer. So P is a pointer and it is going to point to this location. So now P will point to this location. Okay, now what are we doing? We are saying P equals to P plus 1. Because P is a pointer to structure test. Look at this. Because P is a pointer to structure test. Right now, what is P pointing to? P is going to point to 5. P is going to point to 5 here. Okay, and P is a structure test pointer. Now, when I do P equals to P plus 1, when I do P equals to P plus 1, what happens now? Now, what will P point to? P will now point to the second item in this array, right? So now P will point to 4. Now P will point here. Okay, now P will point to 4. Okay, but P is still a structure test pointer. Nothing changes there. Now let's look at this statement. What does that statement do? It says plus plus P arrow C. Now, if you notice, this has higher precedence over this. Okay, this has higher precedence, right? So this has the same precedence as parenthesis, while this is a unary operator. So P arrow C plus plus. Okay, what does P arrow C means? Now P is pointing to 4. So P arrow C will point to this, right? P arrow C, right, will point to the character pointer which is here. That's what P arrow C is a character pointer. Don't forget that P arrow C is a character pointer, right? It's a character pointer that is going to point to B, right? What is it? It's a character pointer. Now I'm saying plus plus this point. So what happens? It will now point to E. Okay. So now what will happen? So this will point to, okay. So sorry. So this will now pointing to, so instead of pointing, so P plus E, because we have this pre-increment of plus plus, it will now point to ET. It will point to E basically. Because it's a character pointer, it will point to E because I've incremented it by 1. Now look at this. Now I'm saying P plus plus arrow C. What I'm doing here, I'm doing P plus plus, right, arrow C. That's what I'm doing here, right? Now because this post increment, it will be done later. First I'll do PC. I'm printing as PC. Where is PC pointing to? PC is a character pointer pointing to E, right? But I want to print it as a string, so it will print till the time it will encounter \0. So it will print ETT. So it will print ETTER in better. Then it's incremented now. Look at this. Because I have plus plus here. Look at this. I have plus plus here. Look at this. I have plus plus here. Now P arrow C. It will first print P arrow C, which is nothing but ETTR. It will print this. Then P will get post incremented. Remember, P here is a pointer to the structure test. So when P gets incremented, what happens now? Now P will point to 6. Right? Because P's data type is a structure pointer. Remember, see, P is right now pointing to 4, right? When I add 1 to it, it will point to 6, the next item in this array, right? So P will point to 6. Very good. So now what do we have? We have star. Now next statement, it is printing a character. And what does it want to print? Star plus plus P arrow C. Now again, what is this equal to? First it will compute this because this has higher precedence. Then I have 2 unary operators, and unary operators associated with is from right to left. Then it will compute this, then it will compute this. Now, PC, look at this. What is PC? PC is pointing to, because P is pointing to this. Remember, P is pointing to 6. PC will point to J. PC will point to J. Yes? And I have a pre-increment. What is PC? PC is a character pointer. Right? PC is a character pointer. So I'm incrementing it by 1, which means PC, now because there's a pre-increment, it will point to U. And now it says value stored at this location. So what should it print? It will print U. So enter U. Those are the 2 things it prints. Okay, so both of them are good. So these 2 are done. Now let's look at the third printf. It says printf %d P0i. What is P? Where is P pointing to right now? P is pointing to 6. So what is P0? P0 means it's the same thing, same location. P0 is nothing but value stored at P plus 0. That's what it is, right? So it will continue to point to 6, or this structure, to be precise, it is pointing to this structure. To that structure, I'm saying dot I, right? P0 dot I. So what would it print now? It will print 6, right? Because this integer has the variable name I. So it will print 6, right? Very simple. So now if you look at all the options now, you have iter u6. That's it. You don't have to even run it any further. Iter u6 is what we got. So no other option has iter u6. This is u8. So option B has to be the answer. Okay. And it's also very simple. Now again, it is printing. If you notice, now what is the final statement it's printing? The final statement it's printing is PC. That's what it is finally printing, right? And if you notice, my PC was anyway pointing to, sorry, my PC, where is my PC now? Sorry. It's all become a confused thing. But it will eventually point to, it's very straightforward, because my PC is pointing to U here, right? When I try to print that as a string, it will print everything till the character. So it will print UNGLE. Okay, you can do it manually, and if you just follow the pointer arithmetic carefully, if you understood the precedence, here there is a lot of precedence here, right? If you're careful with precedence, this problem is straightforward. Okay, so that's good. Let's solve a couple of more problems. Okay. Anyway, we typically solve 15 problems, right? So let's solve a couple of more problems. Okay. Oh, here things will get slightly interesting. So I have a 2D array. Look at this. I have an array with 3 rows with 4 columns, right? That's what I have, right? ARR is a 1D pointer, is a pointer to a 1D array, right? Or it's a double pointer if you want to think about it that way. Okay. So we anyway discussed that in one of the live sessions and the response to one of the live sessions, right? This is what I have. Now, what's PTR? Look at this. Look at this. This is very important, right? PTR is a pointer. PTR is a pointer to a 1D array. That's what it is. It's a pointer to a 1D integer array of size 4. Okay, now it says PTR equals to ARR. Very good. Now let's look at each of these. Star PTR. So what is star PTR? Value stored at PTR. See, value stored at PTR. You can think of PTR as a double pointer, right? What is it? It is pointing to this memory location. So value stored at PTR will give you 1. Right? We've discussed about double pointers and things like that. Now let's look at the second part. It says PTR plus 1. PTR points to the first row, right? So PTR plus 1. Look at, so let me write it down here, right? It's better to write it down. PTR plus 1. Then what do we have? PTR plus 1 plus 2 and then a star. Okay, let's break it down. What will PTR plus 1 point to? PTR plus 1, right, will point to 5. Will point to 5. And what is its type? PTR plus 1 is a 1D, is a pointer to a 1D array that is starting at 5. That's what it is, right? PTR plus 1. Value stored at that. Value stored at that. So this star will make it, instead of a pointer of type 1D, instead of being a pointer to a 1D array, this will become an int pointer. It's an int pointer pointing to 5. Right? Next, I have plus 2. When I do plus 2, what happens now? Int pointer pointing to 7. Right? So I have an int pointer now. Now I have an int pointer pointing to 7. Now what does it say? Value stored at this int pointer, which is 7. So 1 plus this whole thing will be 7. Now let's do this part. Okay, what is that? Star PTR plus 2 plus 3 star. Okay, what is PTR plus 2? PTR is pointing to this, which means PTR plus 2 will point to 9. And PTR plus 2 is a pointer to a 1D array that is starting at 9. Right? And then I have a star here. Because I have a star here, this will no more be a pointer to 1D array. It will now be an integer pointer. It will now be an integer because I have a dereferencing operator on a double. So we discussed this, right? So I have an int pointer pointing to 9, and I'm saying plus 3. Now, because of plus 3, I have a point pointing to this. When I do plus 3, what happens? 1, 2, 3. I have an int pointer pointing to 12. And I have a dereference operator. So value stored at this pointer is going to be 12. So this is going to be 12. So 7 plus 1, 12 is 20. That's it. Okay, so if you've understood the double pointers, triple pointers, or pointers to 1D arrays, all of that we discussed extensively in the course videos and also in one of the live sessions, this should be straightforward. Right? So let's do question 15. Okay, question 15 is also straightforward, to be honest. So I think there is a small trick here from what I recall. Okay, so let's do it. So I have I and j here. So this is 1, 2, 3, 4, 5, 6, 7, 8. I have an integer array called a. For I equals to 0, I less than 3, I plus plus. Okay, so let's say I equals to 0 first. Right, so when I equals to 0, what happens? AI equals to, there is an I plus plus here and there is an I plus plus here. So first I equals to 0, right? I less than 3, very good. So now what happens? I gets, so AI gets incremented by 1, which means this will become 2. But I also gets incremented, right? So I becomes 1. But then there is an increment here also, which means I now becomes equal to 2. Right? Now I becomes equal to 2. Because I becomes equal to 2 now, what happens now? Because I becomes equal to 2, 2 less than 3, very good. So A2 equals to A2 plus 1. This is A0, this is A1, this is A2. Okay, so A2 becomes, gets incremented by 1. So this becomes 4. Now I becomes 3, then I becomes 4. Okay, because I becomes 4 now, I is no more less than 3. This condition will fail, will come out of this loop. So this loop is over. Then it says I minus minus, which means I becomes equal to 3. Very good. Now I has become equal to 3. Now let's look at this for loop. In this for loop, my j equals to 7. Let's look at it. My j equals to 7. Here I'm declaring one more variable called I. So this variable I has the scope of this block. This I is different from this I. As soon as I come out for loop, this I will not exist. Only this I will exist. Very, very important, because the scope of a variable is the block in which it is placed. So this is the block here, from open parenthesis to closed parenthesis. So this I will only live as long as you are within this function. Once you're out of this function, this I is no more. The older I itself is valid, and the older I here has a value of 3. Okay, but so j equals to 7. Very good. So it says I equals to j by 2. So which means this will become 3. So A3 equals A3 minus 1. What is A3? 0, 1, 2, 3. So A3 will become this. Very good. Now what does it say? It says j minus minus. So j will become 6 now, right? So j becomes 6. J is greater than 4. Very good. So now I becomes 3, right? Because I becomes 3, A3 will now again get decremented. So A3 will again become 2, right? A3 became 2. Very good. So now again J got decremented. So J became 5 now. Okay, J is greater than 4. So now I equals to J by 2. So I equals to 2. Now it says AI equals to AI minus 1. So A2, A0, A1, A2. So A2 gets decremented, right? So A2 gets decremented. Yes. Right. Now what happens to J? Now J becomes 4. Okay, J gets decremented. But this condition is no more satisfied, so we'll come out of the loop. Trick. Now it says print I and AI. Lot of people get confused and say I equals to 2. No, I is 2, this I is 2. But this I, because we came out of this block, remember we came out of this block, this I is no more valid. When I say I here, it means this I. What is the value of that I? 3. Right? So it will print 3 and values at the A3. 0, 1, 2, 3. 2. Right? So it will print 3, 2. Okay, this is slightly tricky, but you just, as long as you understood the rules of scope, that the scope variable is within this block. This is a block of code. I declared inside this, so as soon as I come out of this, this variable is no longer accessible. Okay, it's a tricky question, but nonetheless a very good question to trick you with scope rules. Okay, very good question actually. Okay, since we've done 15 problems, let's stop it here. Let me just, okay, let's stop solving problems now, and just a second. Guys, so we have already provided answers. As soon as you finish the questions, you'll get answers. Anything that you don't understand, please reach out to us. We'll give you more detailed answers if that helps you. Please shoot an email and we'll respond back as soon as possible, right? So any questions now, both in test 1 and test 2, close to I think 50 to 60 problems. Solve all of them. Any problem, the solution, if you don't understand, try to, first of all, my suggestion is this: solve the problem. If you get an incorrect answer, struggle with it for a day or 2. It's perfectly okay, because that struggle teaches you problem solving skills. Trust me. It's like going to the gym and sitting or marathon. Okay, I've never gone to a gym, but I've done long distance running long back. Okay, so I understand you have to be on it. You have to literally be on it day in, day. Okay, so practice for it. If you still cannot understand the problems, right, or struggle with it, if you can't solve it, look at the answer after a day or 2. If you cannot understand the solution, please do reach out to us. We are here to help you. Okay, we want every student's effort to matter. Okay, we'll do everything we can, give you more detailed answers if you're stuck. Okay, sounds good, folks. Have a good weekend, and you'll start linear algebra content by tomorrow end of day. The content that you will study for Monday, you'll get it tomorrow itself. Okay, and we'll also put out the schedule, send out the schedule for linear algebra, and we'll do it slightly slowly to accommodate those students in third year and final year of BTech who have exams now. Okay, thank you for joining in, and sorry for the small glitch we had in between where my broadband connection dropped off. Sorry for that. Otherwise, nice. And yeah, have a good weekend. Revise everything. Let's again start afresh with linear algebra. Looking forward to it. Again, mathematics is something which is my first love, so want to dive into it. I'll try and do as many. I'll also provide you some nice pointers, books, video lectures, animations, and things like that. Because one thing that I've often noticed with linear algebra is a lot of people teach. So all of us learned about determinant of a matrix. All of us learn about how to compute determinant. I think in 10th or 11th class, we all learn about matrix vector multiplication, matrix multiplication. We learn about all these concepts, right? We learn about eigenvalues, eigenvectors, solving linear system of equations, rank of a matrix. You all must have learned this in a BTech first year, second year. Some of you in 11th and 12th classes, right? But the problem here is what many people fail to answer. Okay, I know this firsthand because I've done like hundreds of interviews for machine learning roles. For machine learning roles, so we have a round called basic mathematics for most machine learning roles, which I've done extensive interviews at Amazon. I used to ask very simple things. I used to ask them, tell me what is the geometric meaning of a determinant of a matrix. People will tell me definition, all the numeric stuff. I say, what does it mean intuitively? What does determinant mean? Tell me, what does the vector matrix intuitively? What does eigenvalues and eigenvector mean? And I've seen people with great credentials on their papers from top-notch universities who can't answer these simple things. Okay. Try to cover linear algebra. I'll try to provide you intuition into linear algebra through geometry, while also giving you all the numerical aspects of it. We learn how to calculate determinant for a 3x3 matrix. We learn all of that, but we also learn it from an intuitive standpoint on what does actually a vector mean in the real world. How do physicists use it? How do various engineers, not just computer science engineers, right? How do various types of engineers, with electrical, mechanical, all of them use it? Of course, I'll not be able to go deep into applications because I'll tell you one application, right? We use matrices a lot for building recommendation systems at Amazon, right? Suppose you're looking at a page, right? Wherein you're trying to buy, let's say, a laptop. There will be a lot of similar products or recommended products, or people who have bought this also bought this, right? So that is powered by a very simple operation in matrix algebra or in linear algebra. So that's the recommendation system, right? At the core of a recommendation system is your singular value sorry, I don't want to use singular. Is your eigenvalues, eigenvectors. I don't want to go into more advanced terms called singular value decomposition. So one of the simplest ways to think about building, so to build actually these recommender systems, there's a lot of math which is very similar to eigenvalue and eigenvector decomposition that you all might be aware of, right? Similarly, there are a ton of stuff. I mean, again, I've done this once for the AA course, so I have some practice there. So I'm looking forward to teaching you linear algebra, both from an intuitive standpoint and also a numerical and mathematical standpoint. Okay, see you from Monday, and let's get going. Sounds good, folks. Joining on a weekend, spend some time with family and friends, take some break. Let's again get started from Monday onwards. See you. Bye-bye.